Hi everyone, my name's Louisa, and today I'm going to be walking you through a more complex problem where we have to find the equivalent resistance in a circuit. Alright, so I've drawn here what looks like a very complicated circuit, but the way I've simplified it a little bit is that I've said all of these resistors are of equal resistance. They're all resistance R. And now we want to find out what the total resistance is for this entire circuit. Now, you probably realize it's going to be a little bit more of a complex process because you can see that some of them are in parallel, some of them are in series, and it's sort of unclear how the whole thing fits together. So the key to solving a problem like this is to look at the things that are most closely linked together and replace those and then work your way outwards to a larger loop. So for instance, you can see right here that these two are in parallel with each other. That's a very, very small, very specific point in the circuit. Those two are directly in parallel to each other, so we're going to replace those. I'm going to circle one more thing that's also very close, which is these two right here. They're in series with each other, they're very close together, so we're going to replace that too. Now, I just want to alert you to some potential errors. You don't want to look at this one and one of these two because we're going to replace this gray loop with a single resistor, and then that resistor will be in series with this one. But until we replace it, this one relates to these two in a slightly more complicated way because those two are in parallel with each other, and then the equivalent resistor to them would be in series with this R. So anyway, the important thing to note is that you want to look for things that are super close together, two that are directly in parallel and not in parallel with anything else or not in series with anything else, and then these two which are directly in series and there's no other resistors that could be interfering with that. So let's start with the two grays. They're in parallel, so we're going to do 1 over R equivalent is equal to 1 over R plus 1 over R. In this case, R1 and R2 are the same thing. And that, I'm just going to multiply both sides. No, I don't even need to. It's just going to be 2 over R. And then R equivalent is going to be R over 2. So, let me just do some erasing here. A lot of erasing, really. Try and keep this neat. I'm going to replace it with a single resistor with resistance R over 2. And so now, let's go back to the other one that we said we were going to look at first. We've got R plus R, and we're just going to say that's 2R. So I'm going to erase this too, and replace that with a single resistor. It's just 2R. Let me do it in red since I did the other ones in red. And now we've got a couple different things going on. This last step is actually a little tricky. It's actually a few steps. I purposely made this a little bit of a tricky problem. So the easy thing is that you can see these guys are in series, so we're just going to add them all together and we get R plus R over 2. So it's 2R plus R over 2 or 5R over 2. I'm going to erase this. At this point, I'm guessing that you guys are probably pretty familiar with the idea of adding resistors to get adding resistances when they're in series. So we've got a total of 5R over 2 here. And now let's take a look at the different paths that electricity can flow here. We can say there's this blue path where it goes through that resistor, and it goes down, doesn't pass through any other resistor over there, and then it goes through this one. So if electricity takes the blue path, then we've just got this one and this one in series. But what if it takes this yellow path? It goes through this one, doesn't go down, and it goes through this one, and then it goes through this one too. So then this one, if it goes through the yellow path, it goes through all 3 resistors that are remaining in series. Now the trickiest concept to grasp here is that those two loops actually represent two resistors that are in parallel with each other. To summarize that, I'm going to draw another tiny circuit down here that has maybe a little bit easier to understand what I'm trying to get at. So this little circuit is a simplified version of the large and complicated circuit that we started with. As you can see, we've already reduced down to these 3 resistors, which is pretty good. We're pretty close to being done. But we've still got 2 possible paths for electricity to take. And if electricity travels along the blue path, it's going through those 2 resistors. And if we simplify those 2 resistors down to a single resistor, we can say that that's this blue resistor that I've drawn here. And now if it goes through the yellow path, it's going through 2 of the same resistors, but when we simplify, we're going to say that it goes through a different resistor entirely. We're going to say it goes through the equivalent resistor to those 3 resistors that it passes through. So it passes through the yellow R, which is a separate equivalent resistance based on the path it's traveling through. So this is a little bit tricky to grasp, but the idea here is that there's 2 different paths that electricity can take, and therefore we can write it as 2 resistors that are in parallel with one another. So to simplify, we just need to find the total blue, the total yellow, and then do our last calculation, which is the resistance in parallel of the blue and the yellow R. So the blue R, we've got this 5R over 2 plus 2R, which is pretty easy to calculate. So we have blue R equal 9R over 2, and the yellow is the same thing except there's plus 1 more R. So the yellow R is 11R over 2. So the last step is just to combine these 2 as if they're in parallel, because they are in parallel. So we're going to do that by doing the 1 over the blue, which is 2 over 9R, plus 1 over the red, 1 over the yellow, so it's 2 over 11R equals 1 over R equivalent. It's a little bit trickier because they don't have the same denominator like they did before, sadly. So we're going to multiply both sides by 11 on there and by 9 on here. So we're going to end up with 22 over 99R plus 18 over 99R, which is just 40 over 99R. And then all we have to do to find R equivalent is flip this, and we get R equivalent is equal to 99R over 40. And that's the equivalent resistance for the entire complicated circuit we found at the beginning.